Welcome to 28th lecture. In this lecture, we'll study expected time to absorption in a Markov chain. In last lecture, we studied about the absorption probabilities, and gambler's ruin problem. Right. In this lecture, we'll study the expected time in which the Markov process is absorbed in one of the absorbing states present in the chain. So expected number of steps until the a recurrent state is entered, and we know that once the process enters in a recurrent state, it stays there forever. So mathematically, it can be represented as the expected value with minimum number of steps times steps, and time steps are greater than 1, given that xn is a recurrent state, that after n time steps, the process enters in a recurrent state, given that initially it was in a transient state I. So initial position is important because the time to absorption will be dependent on the initial state, initial transient state, in fact. Right. The value of mu I, if I is a recurrent state, mu will be R0. For recurrent states, we compute mu using a basic formula, or deriving a formula from the basic formula for long-term probability that we studied in SP26 lecture. So in SP26, in lecture SP26, we derived this formula for long-term probability of R, and this formula was also for transient state. We studied there that this formula is for transient states. So using this formula, we can derive a formula to compute mu's, the average time. So if you multiply on both sides, the left and right hand side, with I, so I times AI, and we sum it over all possible values of I, the initial state I, and for all possible values of the initial state, it would be mu I times a probability of I summed over all possible values of I will give us, this formula will give us the expected value of I, mu I. And we'll have to apply the same operation on the right hand side, and we know that from the basic regression formula that we studied maybe 7 to 8 lectures before, that if I is the starting point, j is the next point. J refers to a time step, that is the next step, just next step to the starting point I. So the distance between I and j states is 1 because they are just neighbors. So it can be this summation I from 1 to m can also be written as 1 plus the summation over j. 1 plus the summation over j. So this can also be written like this, and this portion can be excluded out of it, written as 1. Oh, sorry. This portion can be excluded and can be written separately, and of course this is mu j. So the formula for to compute mu I is 1 plus the summation of the transition probability times the mean value of j, and this formula is true for all transient states. This formula is true for all transient states, and mu for all recurrent states is a 0. Right, and we have written this formula once again. I have written this formula once again for you, and there is an example that will illustrate this concept of time to absorption, expected time to absorption. Right. So given this chain, this is the same gambler's ruin chain that we studied in last lecture. Expected number of steps until the gambler is ruined, or he or she wins. So we have two absorbing states in this chain, this state number 4 and state number 0. So expected number of steps before he or she is ruined or he or she wins, starting from $1, $2, and $3. I mean, starting from this point, or this point. For all these three starting points, we have to find expected number of steps until the process enters in one of the two absorbing states present in the chain. So we'll apply the same formula that we have just derived. This one for all transient states 1, 2, and 3. And once we do that, we'll put mu0 is equal to 0 and mu4 is equal to 0, because for the absorbing states, we know that for absorbing states, mu's are zeros. Mu's are 0. And solve this, mu1 becomes 1 plus 0.5, mu2, the same formula we apply for mu2, the same recursive formula for mu2, for mu3, and finally we have written these equations once again. We see that the formula for mu1 and mu3 is the same, and we put these values, these expressions mu3 and mu1 in equation number 2 from equation number 1 and equation number 3, and then we find mu2 is equal to 4. This means starting from state number 2, we expectedly take 4 steps. The process expectedly starting from here, starting from this state, on the average, starting from this state, the process on the average takes 4 steps before it is absorbed either here to the left hand side or to the right hand side. And for 1 and 3, the steps, the expected number of steps are 3 and 3, because they are symmetric, because of the symmetry of the shape, because of the symmetry. From here, starting from 1 or starting from 3, it takes 3 steps to absorb either in state 4 or in state 0. Right, that's all for this lecture. We'll continue studying more about absorption in our upcoming lectures. Thank you.